在本场议题中呢，我们邀请到了讲师，他从行动游戏的开发设计到建立独立的游戏工作室 Dyadic Games， 他是一位真正的游戏开发热血人士，他将带我们探讨一种可以替代官方 Unity DevOps 的替代解决方案，可以使得小型的独立游戏团队也能从 CI/CD 的流程中受益，并引导听众逐步设置并使用 Unity Perforce Helix Core、Perforce Helix Swarm and TeamCity 的整个工作流程，以有效提升开发效率以及品质。Let's welcome Dyadic Games CEO Stefan Kohl with a round of applause.
Yeah, good afternoon, everybody. My name is Stefan Kohl, and I'm very glad to be here. Unfortunately, I couldn't make it in person because while I was preparing this talk, my laptop for the presentation broke. So I'm now streaming from my office computer, and I'm glad that we still figured out the solution. So great thank you to the team for helping me with that. My talk today is about DevOps for Unity with Perforce and TeamCity. And before I dive into that, I want to quickly introduce myself. So I started in the game industry as a mobile games developer in 2013. And because the company used low-level C++ game engine for 2D games, I also started learning Unity by myself in my free time. And because the work content didn't after 3.5 years fulfill me enough, so I decided to become a freelancer and look on a variety of different projects. So I did during this time game, but also non-game projects and Unity projects, but also projects in other frameworks than Unity. And in 2019, I relocated to Taiwan. I set up Dyadic Games with a local team over here. And now we develop our own products, a game, a tool based on Houdini. And we still do projects for our clients. The client projects are mostly in the field of gamification, educational games, but also industrial applications of visualization and 3D. And this is also why we set up Dyadic Solutions as a new company this year. So in parallel to Dyadic Games, we will specifically focus on 3D solutions for industrial applications. So you can see I have a lot of background in traditional non-game related software development. So I'm not a full-time game developer, but I always try to bring the best practices from the software development field into game development as well, especially when it comes to workflows and pipelines and optimization. And this also brings me to my today's agenda. I want to talk about DevOps and explain why I think DevOps is also a very important topic for indie game development or for game development in general. Then I want to quickly introduce a product called Unity DevOps before going over to the main part, which is where I present a custom CI/CD pipeline with Unity based on Perforce and TeamCity. And the main part of this presentation will actually be a practical demonstration of how to use this kind of setup. And in the end, we have time for Q&A, but if there are some questions in the meantime, you can also interrupt me if this is technically possible over here. So let's see. So what is DevOps? To explain it very shortly, it's a set of cultural philosophies on collaboration and practices or technical practices on automation. And this was, I think the term was coined around 15 years ago, and basically to address the rising challenges of software companies, which face increasingly faster release cycles, quick reactions to user feedback, and also cloud infrastructure. So DevOps is basically here to address the challenges of these modern approaches. Let's first talk about the philosophy on collaborative culture. Originally, so if you take a look on the right side here, originally you had a developer team, and this one was one closed cycle. So the development team had their own process, and you had an IT operations team, or just an operations team in general, and it was their own closed cycle. So you had these two closed cycles which barely ever worked together. And the collaborative culture idea of DevOps is basically about breaking up the cycle and connect the processes of these two teams together into one closed loop throughout the entire product lifecycle. So this is about the collaboration culture. And when it comes to automation, it's mainly about specific technical practices. For example, continuous integration and continuous deployment, in short, CI/CD. And this will also be the main focus of the talk today. There are other practices as well, like microservices, infrastructure as a code, monitoring and logging. But today we will mostly focus on CI/CD. So you might ask yourself now, if you're an indie developer in a small team, or maybe you're a solo developer, why would you want to deal with DevOps? Because it sounds like you're going to add a lot of overhead to a project that is already short on resources. Like this is how it mostly is with indie games, right? Well, the reason is because exactly for that. So you want to get rid of this overhead and you want to save more time. And this can be done when you have a proper pipeline set up that takes care of you. For example, whenever you submit a change to your project, to run some automatic tests and make the builds of the player all coming from the same instance. So you're not using your local developer computer for creating builds, but you have a system that is creating the builds for you. And this will be your single source of truth. So this common scenario when you ship a build and then it suddenly doesn't work in the testing department or with your test players or even the players of the final product. And then what developers often say is, oh, it works on my machine, right? But it doesn't matter because it needs to work on the build that is produced by the pipeline. And this also brings me to the next point. So because you have this pipeline, you can offload all the time that you spend usually on building your product. And you know, when you have a Unity project and you create a player build, it could take 10, 20, 30 minutes or even longer, depending on the size of your project and the performance of your computer. So you lose a lot of time because during that time you cannot work inside this Unity project anymore. And in addition to that, when you create a build, this might include several steps that need to be executed. So if you use addressables or asset bundles, then you need to build them first. And there might be some additional steps involved. And you as a human, you are required to execute the steps in correct order and make sure there are no mistakes happening in between. And if there's a single mistake happening, your build is invalid. But with a build pipeline, it will always make sure that the steps got executed properly. And if one step fails, then it will just stop and it will waste the time of the build pipeline, but it will not waste your own time. So you can save a lot of time. And both the quality improvement and the offloading of the build tasks to a different machine is an initial investment, but it will pay off in the long run. Now, let's talk about Unity DevOps, which is a CI/CD solution from Unity. It was introduced last year, and it is basically a combination and a rebranding of two existing solutions. The first one is the version control system Plastic SCM, which Unity acquired in 2020, and it is now known as Unity DevOps Version Control. The second component is Unity Cloud Build, which also has been around for many years, and it's now called Unity DevOps Build Automation. So these two original products now together combined Unity DevOps. Unity DevOps is now part of Unity Cloud, which is their service platform where they try to integrate all their services. In my opinion, the naming of these tools or services is a little bit confusing, because Unity Cloud should actually be called Unity DevOps based on what I told you before, because Unity Cloud also integrates this kind of performance monitoring services that are very interesting for operational processes. And what is now called Unity DevOps potentially would be better be called Unity CI/CD, because this is what it mostly does. Let's talk about the pricing of Unity DevOps, which I think is its biggest downside. So it comes with a free tier of 5 GB storage and 200 build minutes for Windows that you can use every month. And it's implementing a pay-as-you-go pricing model, which means as long as you don't go over this limit of 5 GB storage and 200 build minutes per month, then you don't pay anything. But as soon as you overstep it, you will be charged for every single gigabyte hour, as well as every single build minute. And of course, if you want to have a more powerful machine, then you have to pay from the very first minute. I wanted to figure out what this actually means in terms of numbers. So what I did is I created a completely new Unity project, and I put in the URP sample that you can, so when you create a new project in the Unity Hub, you can choose some sample setup, and I used the URP sample. I didn't do anything else, so I just used the sample and uploaded it directly to Unity DevOps. And the first build with this free tier took 87 minutes. And then right afterwards, I triggered an incremental build, which still took 60 minutes. So you can see just with the first 2 builds, I spent almost, or more than half actually, of my monthly budget for the free tier. If you have additional requirements, like you want to build for macOS or for iOS, and you need a Mac machine, then you also will be charged from the very beginning. And especially when you speed up this process and you want to do like daily builds or weekly builds, and you really want to take full advantage of the DevOps principles, then it can actually get quite expensive depending on how big your projects are. In addition to the pricing, there are some other limitations that come with Unity DevOps. So it's limited to desktop platforms and mobile platforms. It doesn't have any support for console platforms. It looks like the Xbox Series support is in preparation. So potentially it will come in the future. I'm not sure what about Nintendo and Sony PlayStation. For me, it's very hard to imagine that they will provide it at some point, because the SDKs for these platforms are so huge and so modular, so it might not really be feasible for Unity to integrate it into their system. Apart from the platform support, you are, of course, fully locked into Unity's ecosystem. You have to use their tools, and you cannot really change the workflow. So when you have some custom requirements, you it might be very challenging for you to integrate this into the existing workflow. And in my opinion, the performance of the build platform, especially of the free tier, I'm not sure what you get when you pay a little bit more for it. The performance is very low. So you have to wait very long for your builds, even for a very basic build, and it will be charged per minute. So it's not really that impressive. However, there are also some advantages. So the first one is very obvious. It's smoothly integrated into Unity. So the only thing you need to do is you go to Unity Cloud, sign up, connect your project to DevOps. And then in Unity, there is a nice UI. So it's a window that you can open for version control. You can upload your changes easily. You don't have to deal with any infrastructure. It just works out of the box. And that's quite comfortable, in my opinion. In addition to that, you can get access to platforms that you don't physically own. And the most notorious example is if you develop on a Windows machine and you want to do a macOS or an iOS build, you need to have access to a physical Mac. And it might be a much more cheaper option for you, instead of buying this Mac, to use Unity DevOps to create the builds for you. So in conclusion, if you have a very small project, potentially a mobile project, and you quickly want to get into this topic, then Unity DevOps might still be a valid choice for you. But also, if you don't have a Mac, for example, then it can help you to overcome this gap. So in case you have higher demands or need more ways of configuration, then this is what I'm going to introduce to you now, is maybe a solution for you that could work. So I will introduce you a CI/CD pipeline based on Perforce and TeamCity. Perforce is a version control software. So in our setup, it's going to replace classic SCM or Unity version control. And it is a software developed by Perforce Software, a company set up in 1995. And it's very widespread at game studios. And the reason for that is because of its native support for large binary files. So you could add in gigabytes of binary data and it will perform quite well out of the box. It's not like Git, for example, where you have to add some plugins to handle large files. Unlike Git, it uses a centralized approach. So there is this one server which manages all your files and also the database, including the database of all the users and all the workspaces that are connected to it. While when you compare to GitHub or Git in general, Git is decentralized. You have your repositories, but there is no assumption to be made like where is the origin of this. You have to define it by yourself. Perforce is a suite of several pieces of software. The most important one is Helix Core server, also called P4D. So this is the server software that needs to be set up in order to get the whole system running. And in addition to that, you also need a client. So there are two different clients available, the command line client P4 and the visual client P4B. And I also listed another tool called Helix Swarm. This is a source code review tool. This is optional, but we are going to use it later. So I also want to mention this here. Perforce also has a free tier. It's otherwise paid software, so you have to pay licenses. However, the free tier includes 5 users and 20 workspaces. If you have a small team and these 5 users are not enough, what you can do, you can share one user account with several team members, and then just each one uses their own workspace. So you can bypass this limitation for up to 20 users theoretically. But if your team is already that big, then you might consider just licensing it. Then maybe you would have the means anyway to do so. The second solution I want to introduce is TeamCity, which is going to be the build automation tool in this alternative setup. And TeamCity is a CI/CD solution from JetBrains. So the typical setup you have is you have one TeamCity server, and you need at least one build agent or more if you need it, that connects to the server. So the build agents will take care of all the build process, and they take the actual workload from the server. TeamCity also comes with a free tier. So in the free tier, you have 3 build agents, which might not sound like too much, but for example, you can have one build agent for Windows, one for Linux, and one for macOS, and then just install multiple development environments in one single build agent. And for an indie game team, this is still enough to scale up. And of course, you have 100 build configurations, which is more than enough for 1, 2, 3, or even more projects. And again, if these requirements, if you reach the limitations with these requirements, then you might already be at a size where you can afford buying the license for it. So the most well-known competitor of TeamCity is Jenkins. I think you might be more familiar with Jenkins compared to TeamCity. The strong point of TeamCity compared to Jenkins is its easy installation and its user-friendly interface, and it also comes with a very good documentation. It also has a very extensive plugin library, which means when you need integration for a specific development environment, it's very likely that you just, it's either already available or you can just install it as a plugin, so you don't have to search for any custom solutions. However, the negative points when you compare it directly with Jenkins is it's not open source, and you still have these limits with the free tier. So you always have to plan your pipeline within these limits if you don't want to pay for it. And there is also less community support because the support is mostly handled by JetBrains themselves. All right, this was the theoretical introduction to this topic. And now comes the main part where I want to demonstrate how to set up a CI/CD pipeline based on these tools, how to set up the projects inside, and how to actually use it. So we have a very tight schedule now. I quickly go over the main tasks we want to achieve now. So the first task is setting up the infrastructure, and I decided to do it with Docker. The main reason is for this 1-hour presentation. I think it's the quickest way to really set up an entire infrastructure based on code, and I wanted to include the setup part in this talk because when we talk about CI/CD, it's not only about using the system, but also understanding how to deploy it and how to maintain it. So I didn't want to cut this out. I wanted to be part of the whole presentation. And for Docker, I use the Swarm extension, which means you can create a cluster of containers that are distributed across several machines. So other than the default Docker setup where everything is on one machine, the Docker Swarm allows you to use containers connected together from different machines. And this is very interesting when you want to use, for example, a TeamCity build agent that runs on Mac that is connected to your infrastructure, which otherwise would run on Windows and Linux. So you can integrate these different build agents together. Once we're done with the infrastructure, we're going to set up the project. So we create a dummy Unity project, we upload it to the version control software Perforce, and then we set up the CI/CD pipeline inside TeamCity. And as a final step, we want to set up the review workflow inside Helix Swarm. And once, after we've gone through all these steps, we are finally able to use the pipeline in some practical day-to-day example on how to use it. The entire project is available on GitHub. So I have a detailed step-by-step instruction on how we can set up all these three tasks. It's under MIT license, so you can do with it whatever you want. Just keep in mind, it's not production-ready infrastructure. So it was very quickly set up for this presentation. You can use it as a starting point or to understand how these things work, but I don't recommend it, use it right away for production purposes. So it's more for educational reasons. Okay, then let's quickly get an overview of the infrastructure and the process we are going to set up. So we will have two actors. So we have a developer and a reviewer. And in the center of this whole infrastructure, there is the Perforce server, the version control, and the Perforce client. The client is syncing the project files from the server with the local workspace of the developer, but also with the TeamCity build agents. So the developer, he is changing the local code, and he is synchronizing this with the depot on Perforce. And when he's done with his task, he can use Helix Swarm to request a review. So Helix Swarm then manages the automatic testing through TeamCity. And TeamCity will also report the test results so that the reviewer can get insight if the tests were successful. And at the same time, he can also review the source code, submit the changes to Perforce. So only until then the changes will actually become part of the main project. And then there will be an automatic build triggered on TeamCity, which will then end up as a Unity player build that we can test. All right, then let's dive right into it. So I've checked out the repository already. I hope that this is big enough for you to see. Potentially not. Let me try to scale it up a bit. Yeah, I'm not sure if you can read everything, but in the repository there's a Docker folder, and here you find Docker Compose files for all the services we are going to set up. And there is also an environment file, which I'll show you quickly. That's the wrong one. So it has the password for the super user of Perforce, as well as the password of the reviewer and the database credentials. You can take what is here, but you can also change it to your own needs. So just that you know where you have to start with your configuration. And the first thing we want to do is we want to set up the Perforce server. So I'm going to run a Docker Compose command. So everything what I do over here is documented on the README file in the GitHub repository, so you don't have to memorize anything. You can just later, when you want to try it out by yourself, copy and paste it into your console. All right, so the deployment is done. The server still needs 1 or 2 minutes until it's ready. So in the meantime, we will just go on to the next service, which is Helix Swarm, so the review tool. We are also going to start it. And while the systems are booting up, I want to show you the Docker Compose file, just that you understand what's happening over here. So for the Perforce server, there is no public Docker image, or there is no official Docker image from the developer available. But there are some community solutions, and this one is from SourceGraph, which is more or less up to date. But you also have to keep in mind, maybe in the future, this community member will not care to maintain the solution anymore. So what you can do is maybe fork this image and adapt it to a newer version of Perforce so that you can keep upgrading your infrastructure. So inside our cluster, this, the Perforce server will have the host name Perforce. It will run on port 1666, and the port will also be exposed to our local machine. So we can later call localhost 1666 to access the Perforce server. However, inside the cluster itself, the different services will use this host name to talk to each other. Yeah, it refers to our environment file where the credentials are set. And we also need an external, we also need a volume where we can persist the database of Perforce. Then let's take a look at Helix Swarm. So this one actually needs 2 containers, or 2 different services to run. The first one is Redis. It is a key value store where Helix store is storing its configuration. So this must run as a dependency. And for Helix Swarm itself, it usually runs on port 80, but on my computer, port 80 was already in use. And I don't like it when you set up an infrastructure and some random tool is just using port 80. So I changed it to 8085. However, you can usually do this with Helix Swarm, but the Docker setup script the official Docker setup script that was provided by Perforce himself has some issues with that. So we need to do some additional configuration. So I provided a custom script which does some additional setup to propagate this port. And we still need to do one manual step. So because the problem is the service already get deployed and it doesn't know at that point that we want to use a custom port. So Swarm is talking to the Perforce server, registers itself as an extension, but doesn't give its full information about the new port. So we need to change it manually. And for this, there's a command line command you can use to configure extensions on Perforce. So I also put this in the documentation. We execute this. So let me see. Okay. Maybe the server is not ready yet. Yeah, let's double check if we can connect to the server. Okay, so the server is up. Yeah, everything looks good. I'm not sure why didn't allow me to change the extension. Try this here. Ah, okay, so it worked in the normal Windows shell. So what we need to do is just add this custom port of Swarm into the config file. Then we save the text file and it will automatically be propagated to the Perforce server. All right, we are now done with the Perforce part of the infrastructure. Now let's continue with TeamCity. So we also call Docker Compose for the TeamCity server. And TeamCity also needs a second service, that is the database. So you can see it has a dependency on another container, and this is the database container. In my case, I used PostgreSQL, but you can use others as well if you want. So the database uses the internal host name TeamCity Postgres, so we need to remember this for the setup. And TeamCity itself will run on port 8111. So let's test it out. And you can see it's already booted up. We don't need to restore anything. We start with a fresh new server, so we just proceed over here. We want to use PostgreSQL. Then let's download the driver for this database. So as previously mentioned, the host of our database server is TeamCity minus Postgres. And the credentials we defined were the database called TeamCity, the username called TeamCity, and the password TeamCity 2024. And then we proceed with setting up the database. And very soon there should be a license agreement that we need to agree to. And then that's the setup of TeamCity itself. So let's read everything first and then accept. Yeah, we need an admin user, so I just call everything admin. Yeah, and that's it. So TeamCity is ready now. Since we are using a Unity project later on, we need to install a plugin for Unity. So Unity integration is not part of the original setup that is coming with the TeamCity installation. So we need to go to the JetBrains marketplace, search for Unity, find the Unity support, install it to our local server, click install. And installation is done, and now we want to enable it. So this takes a few seconds. In the meantime, oh, sorry, I noticed the scale might be a little bit too small, so I'm going to zoom in. Yeah, so one final step I want to do is I go to the administration panel. Let me zoom even closer. And at the global settings, I want to increase the maximum size of the build artifacts to 1 GB. That's just in case your game is going to be larger than 300 megabytes. So let's just do this right now and then don't deal with any issues later on. Yeah, the plugin now is also available. And that's it so far for the TeamCity setup. Then, so this is the server. We also need a client or the build agent. And for this one, it's a little bit complicated. There is an official Docker image for the TeamCity build agent, but this image only runs the build agent itself, but not anything else. And on the other hand, we have also some Unity Docker images, which have a Unity editor installed that is community maintained. And what I needed to prepare for this presentation is to create a custom Docker container that merges these two existing Docker images together. So we don't need to go through this process in details anymore, but just that you understand there is a little bit more involved now. So we go into C. So there is a Docker file over here, and this Docker file is basically merging together these two Docker images that I just mentioned. And after we create our custom Docker image, we can run Docker Compose to deploy it. So in order to build this custom Docker image, we need to run Docker build command. And inside, let me show you the Docker file directly. Inside this container or inside this image, we also need to execute Unity in the command line for once, because we need to we need to get the license. So we need to unlock the Unity editor with our license in order to be able to use it. You cannot run Unity without proper license. And this is some additional step that's happening over here. I don't want to pass my credentials through the command line. So what I'm going to use is a feature called secret, which means I stored my credentials inside some text files. So the username, the password, and the serial key, each of them are inside a text file. And I just tell Docker build that they can find the credentials over there. So let's run the build step. And you can see here it executes Unity from the command line. So yeah, it's basically this part, and it also passes the secrets. Yeah, so I didn't check in the secrets to GitHub, so you don't even need to try. Okay, we are done now with the building our custom image, and now we can deploy this image just the same way as we did with the other containers. Let's just double check. Yeah, the reason why it was so fast, because during preparation, I already ran through the build process itself. So you can see all the images that we currently have available on our machine was already basically prepared yesterday. But this is this custom Docker image that we created. And now we want to deploy it with Docker Compose command. So inside the Docker Compose file, we tell Docker to use this image and create a container out of it. All right, and there's one final step. So the agent should be available very soon. And what the agent does is it tries to register itself with the TeamCity server. And you can see now there is an unauthorized agent, which is exactly this container that we just deployed. So what you need to do at the very first time when you deploy this agent, you need to authorize it. And now it's available as a build agent in TeamCity. All right, so we have set up the infrastructure now, and now let's prepare our project. So let's again go back to our Perforce server administration tool. I hope it is not too small and you can see a little bit, but what I am going to do now is I go to the users and groups tab, and you can see there is the super user, that's me, who is just logged in right now, and also Helix Swarm registered its reviewer user. So these two users are already available. And now I'm going to create a new user, and this is our developer, and I call them TGF 2024. This will also be my password, my full name, and also my email address, example.com. And I create this user. And now I have 3 users over here. So the reviewer, the super user, and our developer, TGDF 2024. We also need a depot. This is where we are going to store our project files. And by default, Perforce already comes with a standard depot, simply called depot. We could create another one if you want. You can create as many depots as you want, as long as you don't run out of space. A depot is basically the highest level organization unit of files. So every single file you want to submit to the Perforce server needs to be inside a depot. This is what we have over here now, so we are good to go. And now it's time to set up our local workspace. So if you remember, we finished now the task 1, which is setting up the infrastructure. Now we want to set up the project itself. So the infrastructure is ready to use. So let's use the visual client. And over here, you might not be able to read it, but we connect to the server. So the server address is localhost 1666 because the Docker container has its port mapped to our local port 1666, so we can just connect like this. If you run the container on a different machine, then you have to specify a proper host name over here. The user is TGDF 2024, and we want to create a new workspace now. So the workspace is the local setup of your version control files, and each workspace needs to map to 1 or more depots on the server. And let me do it like this. Open text editor. So this is called a workspace mapping, which means we have our depot from the server, and this is our local workspace. And what we are going to tell here is that everything inside the depot of Perforce should be merged to our local workspace. So that's the most basic setup you can get. You can also have a more complicated setup where you, for example, map several depots to one workspace, or the other way around. You just use part of the depot and map this part of the depot to your workspace. So you have a lot of flexibility over here. I need to define the workspace root, which is a local folder on our system. And then the workspace is fully set up, and we can open the visual client. So there are 2 important tabs over here. One is the depot view, the other one is the workspace view. The depot shows everything what is on the server, and the workspace shows everything on your local machine. So over here, there's the root folder of our workspace, but there is nothing inside. So we don't have anything to submit. This is why we are now creating a Unity project. So I've decided I use the 2D platform micro game, which is a very small game, which has a little bit of game logic and assets inside, but is also not very huge. So we can use it just fine for our purposes. Okay, I will now select our local workspace root that we defined in the Perforce visual client. This is the location where we put our Unity project. I call the project itself TGDF 2024. And we don't need Unity Cloud, we also don't need Unity version control. So let's create the project. Now let's wait until Unity fully created and imported all the assets. Let's refresh over here, and when we keep refreshing while Unity is importing the project, you can see that it slowly builds up. It's a tree of files in your project structure. So I think most of the stuff should already be there. What I want to do now as a first step, and you can find this example also in the GitHub repository. I prepared a p4 ignore file, which works very similar to a git ignore file. It's just a text file that defines patterns of files that you don't want to submit to your version control. For example, the infamous library folder of Unity. You don't want to ever submit this, as well as the temp folder and a lot of other stuff. So this file is ready to use. I just put it inside my Unity project. And that's it. And when I now want to use the convenient and very comfortable way of adding files to Perforce, there is usually a more sophisticated workflow, but we don't really have the time to go into too much of detail. So what I'm going to do is I right-click the root folder of the project. So Unity is ready now. And there is an option called Reconcile Offline Work. And what this does is, from the folder you select over here, it will scan all the subdirectories for changes, which means changes that have not been submitted to the server yet. And because we created a completely new project, everything inside this folder will be detected as a change. So if you can't see it clearly over here, what I get is a list of 1,000, more than 1,000 files. This is basically our entire Unity project. And I hit the reconcile button, and what I now get is a change list. So this is kind of similar on how Git works. So on Git, you have to say add or remove first, and then it will be basically tracked for committing it to the server or to the remote repository. And in Perforce, you use change lists. So I have now a list of more than 1,000 files here, our Unity project, and I want to send it to the server now. And I call it initial submit. And I click the submit button. And now on the depot, you can see that our project is now also inside on the server. So we have it on our local workspace, and we already have it on our server as well. So there are two more things I want to do. And this is basically just to speed up the process a little bit. So in order for TeamCity, we need to set up a build configuration. And TeamCity has the option to load a build configuration from source code. So I've prepared this already. And what I want to do now is I go into my local workspace and I put these configuration files. So it's basically a folder called .teamcity. Let's zoom in a bit. Yeah, and it has two configuration files inside, which later will be detected by TeamCity and then automatically set up the build configurations for us. So let's refresh over here, and now we can see there are two folders, the project folder and the configuration folder. And I also want to add some stuff to our Unity project to fully take advantage of the build pipeline. So I've prepared a Unity package that has some dummy test cases inside. So let's import those. It uses the Unity test runner. Let's just see if it works. Let's open the test runner window. So what you see over here is the test runner in edit mode. And we have 3 test cases here now, which are the one I just imported from my examples. And let's run them. And all 3 of them pass. So it's just some dummy test that basically tests the adding of 2 numbers. So nothing really exciting, but at least we now have test cases available that we later want to execute. And the other thing I want to add are the build scripts. So this is in another Unity package. And the build script is one C# file that, let's take a look, that when being triggered will build the player. Let me copy it to the editor so we can see it better. So it's basically a static class with a static method, and it's called build player headless. And inside there is nothing exciting happening other than triggering a player build and saving it inside a folder called builds, standalone Windows 64. So we are creating a build for Windows 64-bit. What's important, at the end of the build script, I'm exiting the editor, and I will explain later why I do this. So now that we've added this stuff to our project, let's run reconcile offline work again on our project. And we get a list of these new files that we added, and let's submit it to Perforce. Let's call it added CI/CD files. And now the project is set up. So what we want to do now is in TeamCity, we want to create the project, the build pipeline of the project. So what we need to do is we need to specify a repository URL. And for Perforce repositories, you need to use Perforce, where you usually put the protocol, then the name of the server, the port, and the path of the depot. We need a username, which is our developer user. And then we proceed. And what you can see here is now that TeamCity detected that in the depot there is this configuration for the build runners, and it asks if you want to import it. And this is exactly what we want to do. So in order to save us some time, it goes through the build configuration, we just import it directly. Now the project is set up. We can ignore this error for now because we're going to fix it later on anyway, along the way. So what the error basically says is because the configuration file didn't have the passwords stored from the previous setup, so we need to add the passwords manually. The only thing I want to do now is allow editing project settings with the UI of TeamCity. So even though our project build settings are stored inside our version control, we still want to have the opportunity to change it over here. So this is the only change I'm going to make. And now I can show you the build settings that were created. So let's zoom even closer. This is our project, and we have two build configurations. The first one is called build, and it is creating a player build of Unity, and the second one is a test runner. Let's quickly look into it. Let's check the configuration. And what you can see here, so at the general settings, the only interesting part is the build artifacts that you want to store and deploy later on. So because we have this folder called builds standalone Windows 64, and this is basically the files we want to retrieve. We want to bundle them in a zip file, and we do not want to include these folders, which are called do not ship, or back up this folder and don't ship with your game, so we want to exclude those. And the build step itself, usually when you don't use source code to configure your pipeline, you have to manually set this up, but now you can see it's already there. So we have the project name, we call the build player headless method that we provided, and we want to build for Windows 64. What we don't want is the editor to show any UI or any error dialog, so it should really completely run in headless mode in the background. And we also don't want to quit it automatically. We want the build script to quit, because the reason is if you use automatic quitting of the editor, and if the build takes several minutes, then the watchdog of Unity will kill it off, and the build will basically not be finished. On the other way, if you don't call quit from inside the build script, Unity will never quit, and then the build process will also never stop. So it's very important for your Unity build to call the editor quit command from inside the script, but not from here. And now let's take a look at the run tests, which looks very similar. So we have a Unity build step again, but this time we don't call any build script. We also want this time the editor to automatically quit. We still don't need any graphical stuff going on. And we say we want to run tests from the project, namely the edit mode tests. All right, now the project is set up in TeamCity as well. Now comes the final part. We want to set up a workflow for the reviewer. So this is Helix Swarm. I've just seen there is an issue with the background workers. Let me fix that quickly. Yeah, I'm not sure why this happened, but let's get through it. So, yeah, I'm just seeing we're running out of time, so I will try to keep it as short as possible. The first thing I want to do is create a test definition. So for our automatic test, and for this one, we need Helix Swarm to know which API it should call. And in this case, we want to call the API from TeamCity. So that's something that comes from TeamCity directly. And we need to deliver a predefined payload. And here we need to substitute two parameters. And the first one is we need to see the build step that we want to call. And we want to call our run tests build step, because this is now all about testing. And we need the version control root ID, which you can find over here. Substitute it with this. And of course, we need to authorize against TeamCity. So we call bearer token for authorization. We go to our profile of our TeamCity user. We create an access token for Helix Swarm. We copy the token over here and put it over there. And the test definition is done. Now a test doesn't do anything. It needs to be integrated into a workflow. So let's create a workflow first. It's called TGDF workflow. Then let's add the test to the workflow. So what we want to do here is just say whenever there's an update on a review, we want the test to be executed. And now as a final step, we need to create a project. And the project is combining the workflow with the Perforce depot. So what we need to do is we need to create a new branch. It's called branch, but it's basically could also just be in a depot. And the important thing over here is that you add these 3 dots, because this means everything inside the depot path that is specified here. And we want to add the workflow that we just created. And that's it. So we have our Perforce depot be brought together with our workflow. And this workflow will then trigger the automatic test from TeamCity. There is one final thing I forgot to do with the test run in TeamCity. So let's go back to the configuration. Because Helix Swarm now is able to talk to TeamCity and trigger tests, but we also want TeamCity to be able to report the test results back. And we already have the setup over here, but the ticket expired because it is from the previous configuration that we used. So we need to create a new ticket. And for this, we execute this command over here. So our password is reviewer 2024. And we copy the tickets that can now be used for authentication. So did we copy it? Yeah, the connection works fine. So now TeamCity is also able to report back. All right, then let me just double check if the workers are still up. Yeah, looks good. So now the second part is done, and we have 3 minutes left. I want to show you now everything in action. So let's see. It's not connected to Helix yet. So let's start the client again. Let's see. Yeah, they're connected. So what I want to do now, I'm a developer and I want to change something in the project. For example, I want to change the color of this character and do something else. Like I want the character to be red. And I save the change. I run reconcile offline work again. I get my change list. And what I do now is I not submit it, but I request a Swarm review. So there is a separate option for this. And it looks like almost like submitting a regular change list. So I say as a description, change player power. And this time I pick a reviewer, which get notified that there's a new review available. And then I click request review. And now Swarm opens up. So now I'm logged in as the reviewer user, and I can review the source code here. And what's interesting now, because of the TeamCity integration, we also triggered a test run of this change. So you can see test, it's currently in progress. Let's double check with TeamCity. And we should now be able, when we go to our run tests. Yeah, so it's already scheduled. Okay, it currently still runs the initial build. It shouldn't take too long. Okay, so the build is done. Now it's the turn for the test to run. So let's open the details. Let's zoom in a little bit. Yeah, looks good. So all three of the tests that we provided passed. And if everything worked fine, yeah, TeamCity reported back to Helix Swarm that the tests passed. Sorry, to open this one. We can also see it here, test passed. And what I as a reviewer after reviewing the source code can do now is I approve and commit. And now in my local workspace, I can see that, yeah, there is a new change list over here, which means it was the reviewed commit of the reviewer. So it's now part of the project. And now as the final step, so reward for all this hard work, we check again with TeamCity. It should now trigger another build based on the most recent change we made. Or is it already done? No, it's not. Yeah, usually it refreshes once a minute. Let's see, over here it is. Yeah, it's a very small project, so luckily the build doesn't take too long. All right, we are done. So let's check the build artifacts. It's our zip file of the project. Let's download it, unpack. And let's run the game. So I hope you can see that. And we can see that's our red character, tested, reviewed, and integrated in our project. All right, yeah, that's everything for my presentation. And we now have, I hope we still have time for a little bit of QA. But anyway, I hope it was interesting for you to listen, and you might find some ways to apply this to your own workflow. So thank you very much for your attention.
Thank you for Stefan Kohl's sharing. 那我们因为时间的关系，那这场就可能就不开放 QA。那我们本场的议程就到这边结束，谢谢大家的参与。